Hello everyone, my name is Piyush Singh and we are Team Mavericks from Dallas, Texas. Today we are introducing BatoNetra, an AI-powered helmet compliance and rider identification solution. The Motor Vehicles and Transport Management Act 2049 BS in Nepal mandates helmets for riders and pillions. The compliance rate for drivers wearing helmets is 98%, whereas the passengers is less than 1%. This clearly states one thing: the law exists in Nepal, but it is rarely enforced by anyone. Uh, if I'm being honest, हामी सबैजनाले, including me, have ridden a bike without a helmet at least once before. एकजना मेरो एकदम मिल्ने साथी पनि हेलमेट नलाइकन नेपालमा बाइक कुदाउँथ्यो, तर sadly he passed away in a accident. It was a hit and run case and his family never got justice finding the culprit. That was one of the motivations behind us building this project, to help families like his, to solve a solution. While we are building this project, we got to know that there are already existing systems like the one that we tried to build, but it's not exactly the same, as the models in Nepal focus mostly on the red light as well as the speed.
So the solution we came up with is to detect the riders who are wearing the helmets and not wearing the helmet, and also detect the vehicle's license plate of the violators. The prototype flow for our products looks something like this. The input is from CCTV or camera feeds. The processing has a detection model as shown, and the output has the violation record that outputs the image proof and vehicle number plates with blobs and other infos. And the system architecture, the MVP of our for this hackathon looks like this. It has a front end where we upload the video or a photo that's connected with the backend, and that calls the ML model, the detection model, which is connected with the front end output that shows the annotated image or videos. Now moving on to
All
Anis
right,
for the
let's
demo.
move on to the actual demo. All right, so we have the BatoNetra's dashboard here. We upload an image. Let's take a random image for now. And what it's gonna do is detect whether the person's wearing a helmet or not. It's gonna either pick a compliant or a violation. But for each violation, it's gonna try to extract license plates. So as you can see for rider 6, there's a violation, so it's gonna try to extract license plate for a violation. Let's move on to one more example. Let's say this. Okay, as you can see, there's a lot of people wearing helmets here, except one person in the passenger seat. So what it's gonna do is try to extract license plate from that violator. Okay, so rider 8 is not wearing a helmet, so without a helmet, so what it's trying to do is extract license plate from violator. So for these images, we don't have a clear license plate. Let's try to find an image with a clear license plate. So the OCR, so that the OCR is working and we are trying to extract the data or text from license plates. So from Nepalese fonts, it's a little bit inaccurate for now, but it should do the job. So what if there's no violations in a picture? Let's take a good case or a happy case for this example. So for a happy case, what it does is if everyone's compliant with the traffic rules, it's actually gonna escape or bypass the license extraction algorithm, which is better for heavy models and tools that can be integrated into security cameras. All right, so by saying that, let's move on to the tech stack. So for tech stack, we are using Yellow V8, DAS11, and ByteTrack for our machine learning. And we are also using Tesseract OCR to extract the text, ASCII text from our license plates. So we are also using a lot of open source data set, and also all of these models are actually open source. We didn't have enough time to actually go on with each and every